Hi folks, Mr. Long here. We're going to do a quick screencast on factoring with radicals, which means rational exponents, right? So what I'm talking about is things like the fact that the cube root of x just means x to the 1/3. So on this side here, that's a radical. Its equivalent form with a rational exponent is x to the 1/3, okay? So it means the same thing. So where we need this in calculus is when we're doing derivatives with square roots and cube roots and things like that, because you're going to have to be able to solve where a derivative equals 0 to get the critical values. So the first thing, let's look at what a common, we're going to look at number 1 here, what a greatest common factor is. By the way, you'll have a link to this Jamboard, and you won't be able to edit this Jamboard, but what you can do, I believe, is copy it, and then you'll be able to go in and mark it up or erase things and try and do questions yourself, things like that. So greatest common factor. So let's go back to grade 10. So here's right there is a group of greatest common factors, or of terms rather, x cubed, x to the 7th, x squared. Greatest common factor. So what's the greatest common factor? So x to the 7th is not common with x cubed, but x cubed is common with x to the 7th. What it really is, it's what goes into. So what divides in common. So x squared can divide into x cubed, x squared can divide into x to the 7th, and x squared can divide into itself. So the greatest common factor is actually x squared, okay, x squared. So we always pick, as long as the bases are the same, we always pick the smallest exponent, okay, the least exponent, so x squared. So if we go to this one, let's go down to b here. What is, I can zoom in on that. What is, if you had that list in front of you right here, what is the greatest common factor? So we know the exponent here, even though we're not showing it, the exponent here is 1. We know that this is x to the 1/2, right? Another way to write that is x to the 1/2. So if you look, what are your exponents? 1, 1/2, and 3. So your greatest common factor is then x to the 1/2, okay, which is root x. Here's another one. Now this is where it gets weird, right? So look at your exponents. You have x and x to the negative 1/2. Well, we know that's the same thing as x to the, that's the same thing as x to the 1. So the greatest common factor here, I have x to the 1 and x to the negative 1/2. So it's always the lowest exponent. In this case, the least exponent is negative 1/2. So in fact, the greatest common factor there is x to the negative 1/2. Okay, x to the negative 1/2. All right, so let's now go on and do some examples with factoring. So what is factoring? Well, factoring is multiplying and dividing by the same value. Okay, that's what factoring is. It's multiplying and dividing by the same value. So as an example, if I asked you to factor, we'll do it right here. If I asked you to factor this expression, 2 plus 8, and I want you to factor that. Well, you know that the greatest common factor there is 2. So what do you actually do? Well, we always talk about pulling a common factor out to the front. Well, here's what we really mean. So we do pull a common factor out to the front, but what we're actually doing is multiplying by 1. Because if I bring that 2 out to the front, what have I done? I've doubled the amount of 2 plus 8. I'm not allowed to just double something and say it's equal. I now have to divide by that same amount. So in fact, the process of factoring is actually multiplying and dividing by 1. Okay, it's multiplying and dividing by 1. That's the process of factoring. So that our final answer would look like this. 2 divided by 2 is 1. 8 divided by 2 is 4. Okay, so that's your process of factoring. All right, so multiplying and dividing by the same thing. So in fact, you're multiplying by 1. You're not changing anything. Okay, let's go to this. So these are already pre-done. And I'm just sort of going to go through and explain them. So In the box here is the original question, 4x minus 6 root x. So that's x to the exponent of 1, right? So the greatest common factor is the least exponent, as long as the base is the same. Exponent there is 1. Equivalent exponent there is 1/2. What's the least exponent that they share? 1/2. So that's the greatest common factor. How do we go about doing that? Oh, sorry, I did an extra step here that I probably should have mentioned. So the exponent there is 1, the exponent there is 1/2. Again, greatest common factor, 1/2. So it's not just quite 1/2 though. Look at that. I've got a 4 there and a 6 there. So it should also have been a 2 there. Okay, so the greatest common factor is in fact 2x to the 1/2. So what I do is I write the greatest common factor there. I'm multiplying by 2x to the 1/2. But I can't multiply by 2x to the 1/2 and keep equality unless I divide by 2x to the 1/2. Okay, so I do that to each term. So the 4x gets divided by the greatest common factor. The minus 6x to the 1/2 gets divided by the greatest common factor. And then I have 4 divided by 2. That's 2. X to the 1 divided by x to the 1/2. Subtract exponents. 1 minus 1/2 equals 1/2. And then if you look at that, anything when you divide something, sorry, you might hear my dog barking. I'm just in our office and he wants to come in with me. What we have here is something being divided by itself, which is just 1, right? So that's minus 3. Negative 6 divided by 2 is, in fact, 3. Okay, so that's A. Let's go through another one. So here's another one. I'm going to factor this. 18 root x minus 3 divided by root x. First thing I want to do with any question like that is represent it with rational exponents, fractional exponents. So this is 18x to the 1/2. And then divide by root x. So remember that positive exponents indicate repeated multiplication. Negative exponents indicate repeated division. We have division there, right? And so that's negative 1/2. So, because it's exponent 1/2, but there's division there, so it's negative 1/2. I need to look at what the greatest common factor is now. Remember that it's the least exponent, the lowest exponent, when the bases are the same. The base is the same, x and x. The least exponent is negative 1/2. So I've got an 18 here. I've got a negative 3 here. So the greatest common factor between 3 and 18 is 3, right? Is 3. So it's going to be 3 multiplied by x to the negative 1/2. That's the greatest common factor. When we common factor, we're actually multiplying by 1. We multiply by the greatest common factor, which means that we have to divide by the greatest common factor. Okay? And you'll notice something interesting here. This is 1/2, that's negative 1/2. So think about that for a second. What is, so you have to subtract the exponents, right? 1/2 minus negative 1/2. Well, that's just 1/2 plus 1/2, right? Which is 1. Okay. Then this right here, first time you look at something like that, x to the negative 1/2 divided by x to the negative 1/2, some people look at that and they go, I don't know what that is. But remember, you're subtracting the same value. Negative 1/2 minus negative 1/2 is no different than 2 subtract 2, 3 subtract 3. It's 0, right? Because you're subtracting the same value. Okay, so what does this become? 18 divided by 3 is 6. X to the 1/2 divided by x to the negative 1/2 is that 1. Negative 1/2, negative 1/2. That is x to the 0, which is just 1. And I have 3 divided by 3. Okay, folks. And then this right here, I probably should put that into a radical at the end. So it's 3 over root x multiplied by 6x minus 1. The thing I would add here is, what if this original question had been equaling 0? Could I solve it now? Yeah, I could. Because I would know that 6x minus 1 would have to be worth 0. And x would have to be worth 1/6. Okay, folks. Okay, last example. So this one here is the exact same type of thing you're going to see when you do your derivatives and you want to set it equal to 0. But again, we're just factoring right now, common factoring. And what we want to do here is so what do I notice here? I would notice that radical sign and that radical sign. What do I do with radicals when I'm doing math operations? Convert them to negative exponents and positive exponents. So that is 1/2, so 1/2. This is divide by root, so it's negative 1/2. So I look at this and I examine it as carefully as I can, and I see a 3 and a 4. What's the least between 3 and 4? 3. I see 1/2 on a base of x minus 3, negative 1/2 on a base of x minus 3. And that's something else I notice that people don't typically see. They don't see this as a base and an exponent, when in fact it is, right? That's what it is. So the bases are the same, therefore the greatest common factor is the least exponent. That's negative 1/2. So what is our greatest common factor? Right there. That's our greatest common factor. Okay, so we start by writing the greatest common factor here. I've got that written out. And now I just rewrite my original question there, there, and now I divide each term by the common factor. Okay, so you can see here, I've got x cubed divided by x cubed. That's 1, and then I've got a 4. That gives me that 4 there. Then I've got 1/2 subtract negative 1/2, which is the same as 1/2 plus 1/2, which is x minus 3 to the 1, but I don't have to put an exponent of 1. On this one here, I've got x to the 4th divided by x cubed. That's just x. Then I've got negative 1/2 minus negative 1/2. Well, that's going to be 0, right? Because you're subtracting the opposite. Or subtracting the same number, rather. And so you're going to get x minus 3 exponent of 0, which is just 1. So that's just x. So I'm almost there. Now what I have to do is simplify this bracket. So it's going to be 4 times x, which is 4x, plus that x gives us 5x. Then I've got 4 multiplied by negative 3, and that's negative 12. Okay, so there's my brackets, done. And then I've got here x cubed from that x cubed, and then I'm going to rewrite this with a fraction 1/2, but I really, if I was being a really good math person, I would have rewritten that as equals x cubed over root x minus 3, 5x minus 12. And then I can see that the critical values here, so yeah, what would the critical values be here? The critical values are numbers that make the derivative worth 0, okay, the slope function worth 0. So looks like x cubed would make that equation worth 0. It looks like, so that means x is 0. It looks like 5x minus 12 would equal 0. So x would equal 12 divided by 5. And then x equals 3 is a critical value because it causes the derivative to be undefined. Okay, and we'll talk more about that in a little bit. Okay, so, and then what you're going to do for your homework for this small section is some practice on factoring, and I put the answers on the next page. Okay, so, but if you wanted to, again, you could copy this entire thing, this Jamboard, and you could, what you could do is just go back and, because you'll have the original, right, if you copy it, and you could erase all of this work here and then try this question, right, again by yourself. So that gives you another 3 questions to do for practice. Okay, folks, hope that helps, and have a good day.